Hello, Daniela. Thank you for your questions. Let's go ahead and take care of these one at a time. And the first question is, how many distinct ways, can the letters here be arranged? Well, you see, the thing is, you've got repeats here. Two M's and one A, two A's, two N's, one G, two E's. There we go. All right. And how many total letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you're going to have here to start with is 10 factorial, right? Okay, so there's the 10 factorial to start with. Now, that would include the idea that all these letters were distinct, but they're not all distinct, because you see you have two M's, right? So you have to take any arrangement that you have, that M's are going to place in two spots, right? So what you need to do is you need to divide away those two factorial ways of rearranging the M's, right? And once you have rearranged, you take a look, there's going to be two spots where the A's are, right? Well, each of those isn't distinct, and so you got to divide away those two. And then you have what? Two N's, you had to divide away those two, because it doesn't matter where they are. And then a G, E, and you got to divide away the two E's, right? And that should take you to the total number of rearrangements that you can see they're distinct, right? Because management itself is the same letter, the same word, independent of where you put the A's, independent of where you put the M's, or the E's, or all those, right? And so I think that takes care of it, right? That's all the repeats. So the basic thing is the full factorial divided by the factorials of the number of repeats. If there were three M's, you have to divide by 3 factorial, because there are three factorial different ways, because then there would be 3 factorial different ways of rearranging the M's that you have to factor away. In any case, looks like we got one of the answers here, 226,800. Let's go for that one, okay? And look at the second question. You dealt 6 cards from a shuffle deck of 52 cards. Find the probability of getting 3 jacks and 3 aces. All right. So, on this one, first of all, how many ways are there of getting 6 cards from a deck of 52 cards? Well, that's going to be 52 choose 6, which is an awfully big number. But I can figure it out. 52 choose 6. I'm going to try to do it with the calculator so you can watch it. 1, 2, 3, 4, 5, 6, divided by 1, 2, 3, 4, 5, 6. So there's 52 choose 6, right? And what I want here is I want to keep that number, and I want to figure out what's the probability of 3 jacks and 3 aces. Well, how many ways, and what this means is, well, how many ways are there of getting 3 jacks? It sounds to me like there's 4 ways, because there's 4 choose 3 of them, which is the same thing as 4 choose 1. There's only 4 ways to get that. How many ways are they getting 3 aces? Well, again, there's going to be another 4. So you can have a total of 16 by the multiplication principle ways of getting 3 jacks and 3 aces, right? And now I can see from these fractions that this is all going to be rearranged, right? There was the number we just started with, right? So if I divide by 16, that's another number. If I divide by 8, that's a number. And so there's what we have right there. We had 16 possibilities, and that works out, once you've reduced it to the smallest terms, to be 2 chances out of 2,544,815, or 16 out of that bigger number we started with, right? Okay, so it's 2 out of this, and that's what you're looking for. And I'm not sure where you got your 1017 thing from. Let you just guess it. All right, let's take a look at your third question. The stock can go up, go down, or stay unchanged. How many ways of it? Well, 7 stocks, right? So how many possibilities for the first stock? 3. How many for the second stock? 3. I think you can see where this is going, right? Times 3, 7 times. And so what you're looking here is for 3 to the 7th. And that number is 2187. There we go. You let me know if you have other questions, and I will talk to you soon.